Hello everybody, my name is Miloš Simić and I'm from University of Novi Sad and I serve as a task leader for task 3 in work package 6. In this task we're doing the decentralized monitorization and reconfiguration management. So the outline of today's presentation will be task objectives, what are the main tasks of this task, what are the APIs that we developed for this prototype. We will see demos, how the tool and services that we implemented is working, and after that we will see in the future how we're going to implement other stuff and what are the integration points with the other work packages and tasks inside this work package. So to start, task 6.3 will develop a solutions for monitorization and reconfiguration management in this system. We will do this task can be separated in 3 specific elements. First would be acquiring the telemetry from the components in the deployed systems. We're gonna use or implement mechanisms to aggregate and propagate telemetry information to train machine learning models, and we will develop solutions for supporting a reconfiguration of the application components at the right time. So change patterns, communication elements or remove components and so on. The system that we developed, that we can see on this slide on the right hand side, will be separated into planes. On the left hand side we have a control plane where the heart of the system and brain of the system is, and on the right hand side we can see 3 machines. At this point will be data layer or machine layer or swarm layer, let's call it like that. Control plane will serve as the brain of the system where users can interact with, create a bunch of objects. We will talk about them later, and all these elements will be propagated to the nodes and the applications inside the swarms. And based on the different parameters, these informations will be propagated on different ways. And inside the system, a bunch of objects that can be used are described with labels, and labels are arbitrary key value pairs which users can attach to pretty much everything in the system. Labels are used to select and identify specific objects that we want to interact with, and labels are also used to create a connection between objects in a loosely coupled manner. This entire system is developed using open source tools. We emphasize using an open metric standard. And if we see the image on the right hand side, we can see that we also have a small CLI application that will be in the interaction with the control plane. Users are used to using CLI tools to interact with a bunch of complex tools, so for that purpose we developed our own. So CLI tool is in the interaction with the control plane, and users using the CLI tool can send off commands, requests, read the data, or whatever else is required. So the APIs that are developed for this, or up until now for this demo, can be separated in 4 different categories. First of all, we have a user management where users can create new users or add new users, add some security elements like groups and roles and stuff like that. Then we have a namespace management. Namespaces allow logical isolation between a bunch of elements in the systems, for example data or security in hierarchical organized virtual swarms. So one physical swarm can be separated logically in multi-layer system, and users can apply different elements to each of these virtual small swarms individually. Resource quota and second profiles management is also developed for the namespaces, where users can add or remove some specific interactions between applications and the container and the operating systems. On the other hand, we have a configuration and configuration schemas. For this, we want our users to be able to configure and reconfigure our system, but to do that properly, we must have schemas. And schemas are here developed so that users who are building their own applications, adding their own stuff in the system, can validate configurations that other users submit to the system. So you cannot submit whatever you want, in whatever format you want. So someone needs to create a schema and said this is the schema for the specific application, for the specific data layer, for whatever. And then when somebody tries to reconfigure stuff, we will compare what is sent and what is said in the schema, and if everything is okay, then this element will be propagated into the system. To propagate elements into the system, we have three specific strategies how this could be implemented. The first one is the entire swarm. It is a direct message we will send to all nodes inside the system. This is a bad idea in main or bunch of cases, but in a case where we have a security breach or stuff like that, that we want to immediately react to the system, you can use this strategy. Second strategy is a key value selector, where users create or add a bunch of key value pairs, and those key value pairs are compared against key value pairs inside the nodes, applications, and all other elements. And we want to do also direct push, but only to the subset of nodes. For example, we want to apply some configuration elements to nodes that only running Linux operating system or have more than 2 gigabytes of RAM or something like that. And the last strategy is we want to send configuration to the elements, but not in a direct way, but in an indirect way. For this, we're going to use a gossip to propagate configurations in the peer-to-peer manner. So users can select a small percentage of nodes who wants to get the message, and then use a gossip protocol into peer-to-peer network. These nodes will propagate this information in between them, and only those who are required to get these configurations will get them, and then they can apply to the system. And last API that we have for this demo is a monitoring system or monitoring subsystem. For this, we have APIs that will collect metrics, that will store metrics for dashboarding, showing whatever user need. Then we will have APIs for the ML models, specifically for the integration with the work package 5. People who will use, or other parties who will use this collected metrics data to train their models and do something on that. And we will also have the API for the custom metrics for specific protocols or specific parts of the system that are not in the application or not in the node, that can be also added to the system and propagated to the dashboard, so that others can also use this specific metrics when they need it. Let's start our demo focusing on general purpose. We will try to demonstrate how natural flow of the interaction with the application will be. The first part of the demo will be the creation of the user, creation of the organization, user authentication to the system. Okay, so the first operation that we have in our system is to register a user. So we will now register a user that will belong to organization C12S. So we will now wait for some time to system register user. And now we have a successfully registered user. After we successfully register a user, we will now log our user into the system. We will enter the password, and the user will be or should be registered. We now have a successfully registered user. Login. So in the architecture for a system, on the right hand side, we saw a few machines. So machines, when are coming into the system, they will register. So these machines are not manually registered. And for this demo, we have 3 virtual machines, of which we will create a swarm, and we have one that serves as a control plane. So we can list nodes that are already registered in the system, and using this command, we can see their average load, memory, disk, and other features of the machines. When we have a registered nodes in our system, we can use a command to show details from our nodes, and we can see here all the labels that are registered for each and every node in our system. When we have our nodes, we can use query parameters to only select the nodes with some specific features. For this feature, we want to show only the nodes that have more than 3 gigabytes of RAM memory. And as you can see, 2 out of 3 nodes have this specific amount of memory. The next feature that we want to demonstrate in our application is the infrastructure features of this system. We will see how nodes are registered into the system. We will show how we can create swarms from the nodes that are available in the system, and we will see how we can create namespaces or hierarchical virtual organization of our swarms. Now when we want to create a dynamically swarm out of our machines, we can use a claim command, and we can query only the nodes that have more than 3 gigabytes of RAM. So these nodes will be used to create our swarm that we can use other or implement other commands upon. Now that we successfully created our swarm, we can now show all the nodes that are actually registered in swarm. And as we can see, 2 out of 3 nodes are now part of the swarm that we intended to do with the first command that will create a swarm dynamically. As we already told, all the swarms that we have can also contain hierarchical namespaces, which will show or isolate the resources and security policies and everything inside our cluster. And when the swarm is created, we can see that we have a default namespace which contains all these informations showed with this command. Now we want to create a child namespace from the default namespace, and we will apply applications and specific elements to this namespace. This namespace will take some part of or some amount of resources out of default namespace, which we will able to create everything else upon. So we will now use a command to create a child namespace based on the YAML file that we printed before. And as we can see, the namespace is successfully created. We have now 2 namespaces in our swarm. We have a default one, which will represent the entire swarm, and then we have this smaller one, which will take a part of resources, which we'll use furthermore to create applications and do a bunch of other stuff. The third part, or the third demonstration of our system, will be reconfiguration part of the system. We will see how we can create second profiles. We will see how we can create configuration schemas, how we can create configuration elements, how we can validate them against some schema. We will also see how we can push these configuration elements to the previously created swarm using 3 strategies. The first one will be the entire swarm, direct basically push. This should be avoided in normal circumstances, but in some critical elements, security breach or some other stuff, this could be utilized. The second one will be key value selector. This is also direct push to the nodes, but this will work as a subset of nodes. Only nodes who have a specific key value pairs or labels will be affected by this change. And the third part will be gossip through to the swarm using a peer-to-peer manner. And for this we used a lifeguard protocol, but in future we will integrate this with the task 6.1 in the same working package. We will see how schemas evolve over time, and we will see configuration deltas, or how configuration is changed over time, so that we can troubleshoot the problems if they occur and find a specific version of the configuration that created the. Now we want to create a simple demo application that will run inside the default namespace. And for this we can see a bunch of informations, which version it is, how many resources will it use, and what second profile is applied to this application. And as we can see, the application is created, and these 2 terminals that represent our virtual machines, we can see that applications or nodes receive the application and their quotas, second profiles, and all the other informations that are needed for this application to be run inside this node. Now we have the applications, and we will now create a schema that will utilize the configuration elements that will be pushed to the applications. We will create one schema with the same name, but in 2 different versions. We want to demonstrate how the schema can evolve over time, and that we can visualize what are the changes in between 2 versions of the schema. Now, as we created two schemas in two different versions, we can now visualize the versions of the schema sorted chronologically. And as we can see, the schemas are shown in chronological order and is the way how they're created. Now we will create 4 configurations. 3 we will use to disseminate our configuration in 3 different strategies that we showed in the slides. And the 4th one will not pass the validation by the schema. When user apply multiple configurations in different versions, we can see the differences between them. We will go over all versions and we can see what is changed, added, removed inside these configurations over all versions that are existed. Now we want to push configuration to our nodes, and as we can see, we will use default strategy, which means the configuration will be pushed to nodes inside the swarm in direct manner, and we can see when the configuration is delivered to the nodes. With this command, we can see that our configuration is delivered to the nodes inside the swarm. And as we can see, in both of our nodes inside the swarm, this configuration is delivered properly. With this command, we can check that the third node that is not part of the swarm will not receive this configuration. As it is not part of the swarm, the configuration will not be delivered. The next configuration we want to push to our nodes using the gossip strategy. As we can see here, the percentage is 50%. This high percentage is due to that we only have 2 nodes inside the swarm. So this means the only one random node will get this configuration, and it will disseminate in between each other. For this purpose, we used Lifeguard peer-to-peer protocol. But in the future, as part of the future work, this will be integrated with the 6.1 task inside the same package. And as we can see, this configuration is delivered to the nodes. As part of the third dissemination strategy, we will utilize also the direct strategy, but not to all nodes. For here, we will use label selector, and for that we created one label with the key label and value 5 to one of the nodes inside the swarm, and we will disseminate the configuration to the nodes only that have a value above 4, as we can see in this first YAML file. Now we can see that out of the three nodes inside, three nodes that we have, two are in the swarm, and only one of them received this configuration, and for the others we'll see that there's no such configuration delivered. The last part of our demonstration will be a metrics feature. For this we will show how we can collect metrics from nodes. We will see how we can collect metrics from the containers or the applications running inside the swarm. We will see two in the different views of our metrics. We will see the CLI view that will show only the specific part of the metrics for the node, for the container, and for the entire swarm. And the last part, we will see a dashboard using the Grafana that will show in detail view for the node and for the specific application running on that specific node. We will also see metrics API that is particularly interested for the working package 5, in which we provide the API for other parties that use this stored metrics. We will also see how custom metrics from the applications can be stored inside their system. It is important to notice that all the metrics that is stored or given to others through the API is or done by open metrics format. Now we want to demonstrate the metrics part of our task. So for this we have many different variants how to show the metrics. We can show the metrics for one specific node. We can show metrics for containers or applications that are running inside that specific node. We can also show the metrics for entire swarm that we have. And for this we show a lot of information that are mostly important for the user, and we also have the view that will show a little bit later that will present much more details about all the metrics that we have. And to see all the more details for metrics for every node, we utilize, as I already mentioned, Grafana. And in Grafana we can show much more in detail view. Basically everything that is sent from the node using Node Exporter and Prometheus, we can visualize. And as we can see, this node is particularly loaded with the traffic and with the processing stuff. So a bunch of metrics are available here, and the users can utilize all these metrics and apply what is needed for the node, maybe add some more resources or switch or transfer the applications or something like that. So basically the Grafana is used as a visual tool that is a little bit easier to follow than what we cannot do with the traditional CLI. Same in detail view we can also show for every individual container running inside node. So if user want to do in detail view for the applications that are running, see their potential problems and bottlenecks and stuff like that, Grafana will also show in detail view for those types of stuff. And the last part of our demo will be to demonstrate how the stored metrics can be utilized by other parties. And for this we implemented a few APIs that other parties can use. One that is in between two timestamps, which we will demonstrate now, and we will get all the metrics that are stored inside the system in between those two timestamps. And it is important to notice that all these metrics that are stored or given to other users through the API, all is done through and with open metrics formats. So other open source tools that support open metrics standard can utilize these metrics as part of their day-to-day work. And the last part of our demo that we want to demonstrate is how we collect the custom metrics. Our system have a gRPC endpoint on which all other applications that they want to submit some custom stuff can do that. all the data that is collected and all the applications that want to collect or send some custom metrics must be in open metrics format. And we have created one dummy application that will send some custom metrics, and we will now demonstrate how we can show this metrics. And as we can see here, we have sent some custom metrics from this demo app that sends some dummy values, but this represents how we can collect and store some custom metrics from protocols or any other part of the application that is needed. The task 6.3 is part of the reconfiguration, and it could be integrated in other tasks inside this same working package. We can integrate with the 6.1 that we propagate the information and swap the lifeguard protocol that we use now to the protocols and elements developed in that task. We can also integrate with the task 6.2 in the same working package. Here we will store some specific elements that are needed in the database that is created in that and developed in that task. With working package 5, we will integrate by exposing stored metrics to feed machine learning models for the future uses. And additional, our system allow extension by allowing other parties or other systems or other elements to consume collected metrics in real time using How Are You topic. And for the future work, we will focus on dashboard developed by us, that all the elements that are shown through the CLI will be in much more friendly manner, especially for the beginner user. We have a graphical interface. We will continue our work on peer-to-peer metrics or collecting and disseminating metrics in peer-to-peer setup. We plan to use OpenTelemetry standard for easier troubleshooting of the problems and how the requests are flowing through the system. We will continue work on integration with the task 6.1 and 6.2 and finish integration with the working package 5.